In this class, let us study about vectors. Vectors are quantities which have both magnitude and direction. We already know about scalars, right? Scalars are what? They are quantities which only have magnitude. They do not have a direction. Now this is what the definition says, that one has direction, the other one does not have direction. But when we apply it, how does this change affect a quantity? That is what we will see. We will take two quantities. Both I will take as AB. One AB, which is a scalar, another AB, which is a vector, and we will see how the quality of having a direction or not having a direction affects them. First, let us see scalar. You already know what it is, right? So what are A and B? A and B are known as the end points of this scalar quantity, and this, its name is written as AB, and AB will be equal to BA. And if this is 4 units, 4 kilometers, 4 centimeters, whatever, so we write AB is equal to 4 units, right? Now come to the vectors. Vectors have a direction. That means they are starting from some place, they are going to some place. So instead of just blandly calling them endpoints, we have to call A the initial point, and we have to call B the terminal point. And here, instead of simply writing AB, we write it with this symbol on top. Now somebody actually asked me that why are we considering only vectors which are going from east to west. So please understand, this does not mean that it is going east to west. It is just a very literal way of, a very figurative way of showing you that this AB has a direction. It is going from one place to another, but that does not mean it is going from east to west or west to east. It's just going somewhere, that's all. And why are we stressing on that? The second point will tell you that, because AB is equal to minus of BA. Now do you see the difference here? And how can you explain this difference in your daily life? Take this as the distance between maybe your school and your home. So whether you come from your school to, whether you go from school to home or home to school, the distance will always be same. It will always be 4. But then consider this as the displacement. Now what is the difference between the two? Distance means 4 kilometers. Displacement means 4 kilometers from A to B. So here it is just the distance between your school and home. But here what is it? It is the journey that you make. There is a starting point, there is an ending point. That is the difference between displacement and distance. Distance is scalar. It is just 4 kilometers. Displacement is vector because it is 4 kilometers from A to B. That is why these are different. These are two different journeys. AB has A as its initial point, but this is equal to minus of BA. And its length, here also 4 units. The symbol we use is this, is equal to 4. So now you see, this is how we apply the definition. This is how having a direction matters. So now from this we go on to types of vectors. We have seen how the vectors behave. Now we will go to types of vector. We will study about two main types of vectors. One is the position vector and the other a displacement vector. We start with the position vector. Now we move on to the position vector of a point A. Take any point on earth. Here A. The position vector gives the position or the location of A with respect to a fixed point which we call the origin. It gives the location of A, or in other words, it is a vector. Its name itself is vector, right? So it is a vector, so it should have an initial point and a terminal point. Initial point is this fixed point O, and its terminal point is A, and we represent the position vector like this, with its initial point O and its terminal point A, both of them in capitals, or you can represent them by just one single word. So a position vector of a point gives its location with respect to a fixed point, and it is represented by OA or this. And the same thing with B. Consider another point B. What is the position vector of B? We can write it as OB or just this. This one I'm just randomly choosing. This you can take any number you want. You can take any alphabet you want. There is no problem with that. But this has to be OB because the first one is the initial point and the second one is the terminal point. So this OB and OA you cannot change. But the alphabet you use, the smaller case alphabet you use, you can take any alphabet you like. So this is the position vector of A. On daily life, on ground reality, can you think of an example? For example, think of your height. When you say your height is 150 centimeters, what does that mean? You are measuring with your feet on the ground. But every time you don't say that, right? So when somebody asks you what your height is, you don't say that my height is 150 centimeters when my feet is on ground. You don't say that. Why? Because it is understood. You have chosen your feet on the ground as a fixed point. And with respect to that fixed point, you say, I am 150 centimeters. So whenever you see a point and you see that the position vector of that point is OA, remember there is a O somewhere. You don't have to say that every time. There is a O somewhere and the vector from O to A is called the position vector of A. Okay, so it is just like how you measure the height. So this is the position vector of a point. This brings us to the next vector, which is called the displacement vector. What is displacement? We already know it is distance covered from one point to another point. So here displacement vector is AB. AB is a vector which has A as its initial point and B as its terminal point. So you see the difference between the position vector and the displacement vector. Position vector of any point is with respect to a fixed point O. And any point you take on the earth, P or Q or R or S, for all of them the starting point, the initial point is this O. And the terminal point is the corresponding whichever point you are taking. That is the position vector. But displacement vector is very specific. It goes from A to B. And how is a vector represented? It is represented as the terminal point minus the initial point, which means B minus A. This is the displacement vector. Let us concentrate on the position vector of a point A. What is it given by? OA, where O is the fixed point. Now we can use any alphabet, right? I will use R. I will use R to denote the position vector of a point A. Let the coordinates of A be X, Y, Z. It is a point on the coordinate plane, on the three-dimensional plane, right? So it will have a X coordinate, a Y coordinate and a Z coordinate. Now let us see what is this position vector. We need a vector, we need a magnitude, we need a direction. So that is what we are going to find out. What direction, how do we express the direction, how do we express the magnitude? Let us see that. Let us draw a 2D plane. 3D plane is a bit, it is difficult to get a full picture in the 3D plane. This will give you more clarity. One we consider 2 dimension, right? Then let us just extend it to Z. So, what is this? This would be X. And what is this? This distance would be Y. So now, consider a unit vector I along the x-axis. It is a unit vector along the x-axis, which means what? Its length is just 1 unit. Now, another unit vector, this time along the y-axis called j. Again, it is a unit vector, which means what? There. So now, what is x? Now suppose x is 5. So what is 5? 5 is 1 plus 1 plus 1 added 5 times. Suppose this is 7. What is 7? 7 is 1 added 7 times. So that brings us to the position vector of A, or in other words, that brings us to R. What is it? I plus yj, but don't forget this is in a 3D plane, right? So there is a z coordinate also. So there is another one vector k along the z axis such that its magnitude is 1, right? So if the z coordinate is z, then what do we write here? It is zk, or in other words, if z is 10, so what is 10? It is 1 added 10 times, or in other words, 1 multiplied by 10. So this is how you express the position vector of a point. Now this is its position vector means what? This will give you its direction. It moves x along the x-axis, y units, centimeter or meter or whatever, y units along the y-axis, z units along the z-axis. But what is its magnitude? What is its length? It is represented by this figure, like this. That is given by square root of x square plus y square plus z square. Okay. Now this is the magnitude of this vector. So we have got both the magnitude and we have got the direction. This brings us to something which is called the direction ratios of a vector. It is nothing but the scalar components of the vector. Of a vector, this is a vector, right? What are the scalar components? What are the numbers that you have here? It is x, comma y, comma z. Now do not get confused with this and this. Do you see the difference? The point is always written in brackets. So when you have brackets, it is the coordinate. It is the coordinates of the point. But direction ratios are just plainly written like this. These are what? These are the scalar components that you see here. And the second thing we learn is the direction cosines. Now see this vector OA. Suppose this makes an angle alpha with the x-axis, beta with the y-axis, gamma with the z-axis, then direction cosines is cos alpha, cos beta and cos gamma. But what are they? What is cos alpha? Look at this. Alpha comes here. So what is cos alpha? The length OA is what? We have found OA to be R. So cos alpha is adjacent side by hypotenuse. Similarly, what will be cos beta? Y by R. What will be cos gamma? Z by R. So these are the direction cosines. Now we have expressed it in two different ways, right? One with angles and the other with the coordinates and the magnitude. So instead of getting two different ones, we will just name it as L, M and N, where L, M and N are the cosines of A. Then how do we write it? If a point is x, y, z and its magnitude is R, then its direction cosines are x by R, y by R and z by R. So I know there are too many things written here. So we will just take one example and then everything will fall into place. But I just want to tell you one thing, one main difference between direction ratios and direction cosines. Direction ratios you can have an infinite amount. Why is that? Ratio, that is why we call it a ratio. If I say 1:2, I can get infinite number of ratios. 10:20 or 4:8 or 5:10. There can be infinite amount of direction ratios. That is why you will often see the question, it is phrased as proportional to direction ratios. So you can get any time. There is a basic one which we call the direction ratios. And similarly, one important thing you have to learn about direction cosines. They are related with a formula which is L square plus M square plus N square is equal to 1. Why is that? Square all the three, you will know. See? L is x, the whole square, right? The whole square, and add them If you add them, you will see it is x square plus y square plus z square by r square. But then, what is r? R is the square root of it. So square both sides, what do you get? You get 1. So the direction cosines are related to each other in this way. Consider a point, say 2, 1, minus 3. So this is a point. What is its position vector? Let us call it r. What is its position vector? Its position vector is 2i plus j minus 3k. What is its magnitude? Its magnitude is represented by square root of 2 square 4, 1 square 1, minus 3 square 9. So that would be square root of 14. So you have got its magnitude. Next, what are its direction ratios? 2, 1, minus 3. What are its direction cosines? 2 by its magnitude 1 by this minus 3 by square root of 14. Now square all the three of it, add, and you will get L square plus M square plus N square is equal to 1. Now come to addition of vectors and two laws regarding the addition of vectors. How do you add them? Very simple, right? Just add I and I, 3i plus 2j, and there is no k. How do you subtract them? Just subtract, right? Each I separately, j separately. So you get I minus 4j plus 2k. Correct? So now how do you multiply a scalar with a vector? Now you notice the difference. We added two vectors. We subtracted two vectors. But we did not multiply two vectors. We have taken one scalar and one vector. Why is that? Multiplication of vectors is one complete topic. There are two ways by which you can multiply two vectors. One answer will be scalar. It will be a number like 1, 2, 3, 4. The another one will be a vector. So the product of two vectors can be done in two different ways. One which gives you a number as an answer, another one which gives you a vector with a direction and all. So we are not even going there. We are just multiplying it with a number. Let that number be 2. So multiply 2 out by 2. Then what do you get? Now this vector, this lambda, whichever value of lambda you take, lambda r will be parallel to r, but one small condition. If this lambda is positive, then lambda r, suppose this is r and this is lambda r, they will both be parallel and in the same direction if this lambda is positive. But if this lambda is negative, it will still be parallel but in the opposite direction. So depending on whether your lambda is positive or negative, the direction will change, but it will still be parallel. Okay. So now this this addition follows all the rules, like it is commutative and all of that. Now we come to two rules, two laws. One which is known as the parallelogram law of addition. That is what we see first. So how to add? Now we will see a parallelogram law of addition. So take two adjacent sides of a parallelogram. What do you mean by adjacent sides? They have a common vertex. So suppose A. Take two adjacent. That means for both of them the initial point is A. Then the sum of these, where we are representing the adjacent side by vectors. So suppose this is A and suppose this is B. Then the parallelogram law of addition gives you a way to find out A plus B. It says A plus B is actually the diagonal. Which diagonal? There are actually two diagonals, right? Complete the parallelogram. You will see two diagonals, one going this way, one going this way, two diagonals, and it can be taken in any direction also. But it says the diagonal which is co-initial, see, to both A and B. What is the initial point of both of them? A. So take this side, this diagonal, let us name is C. So AC is actually A plus B, and all of them have the same initial point, right? So this is what your parallelogram law of addition says. So two adjacent sides, the diagonal gives their sum. Now from this we come to another law known as the triangle law of addition. Now here we said adjacent sides of a parallelogram, but here saying adjacent sides does not make any sense. Why is that? Because in triangle all the sides are adjacent, because there are only 3 sides. We say the sides taken in the cyclic order. Let us see what that means. Just take this part. I will just recreate this one part here. What part is that? A and B and C. A we know to be this, be represented by the same thing. Okay, you see the difference here? Here the two vectors were two adjacent sides of a parallelogram. Here the two vectors are what? They are the two sides of a triangle taken in the cyclic order. Then how is their sum represented? Their sum is represented by AC. Here A plus B is represented by AC. Now, which direction is AC? You see, direction is in this way. So the sum of two sides of a triangle taken in cyclic order is given by the third side, not in the cyclic order. In the cyclic order, it would have been AB, BC, CA. But it is not in the cyclic order, it's the other way. It is given by AC. Now, before we go, one more thing. We have given one diagonal, right? We saw that one diagonal is A plus B. But there are two diagonals, right? What about this diagonal? Now, I will just recreate this section, not the whole parallelogram. Just this one part, BD. What is this BD? This is A going in this direction. This is B going in this direction. What is BD then? Apply the triangle law. What does the triangle law say? AB plus BD is equal to what? In the cyclic order, but not here. It goes this way, which is AD. That means BD is equal to what? AD minus AB, which is B minus A. So one diagonal is A plus B, another diagonal is B minus A. So this brings us to something called the section formula. We will see what it is. Suppose you have a vector, a displacement vector AB. This is the position vector of A. This is the position vector of B. And then suppose there is a point C which divides AB internally in a ratio m is to n. Then what is that point? Then that is m into B plus n into A by m plus n. So in particular, if the C is the midpoint, then what do we have? Both m and n will be 1. So what will you do? You will just add A plus B divided by 2. So in particular, if C is a midpoint, that will be your formula. Your formula will just be A plus B, both m and n are 1, so divided by 2. So this is if C divides it internally, it is a part of the line AB, then the position vector of C is given by this. But then, what if it divides it externally? It is not here, it is somewhere outside. Then the position vector of C will be same, the ratio is same. Then it would be MB minus NA by M minus N. This is the section formula. Now we will go on to do some questions, but then before that let me tell you one thing about the unit vector. Look at this question. What are the direction ratios? Your A is given by 3I plus 4J minus 2K. What are the direction ratios? It is 3, 4 minus 2. 9 plus 16 plus 4, which is square root of 29. And what are the direction cosines? They are 3 by square root of 29, 4 by square root of 29, minus 2 by square root of 29. What is the unit vector along A? Now you see, if a vector is denoted by this symbol, its magnitude is denoted by this symbol, a unit vector is usually denoted by this symbol. This is a vector. Its length is square root of 29. What should be the vector if its length is 1? A unit vector along the same direction would be 3I plus 4J minus 2K by square root of 29. In any, not only in this case, in any case, if you have a vector R, a unit vector is given by, we use R everywhere. So please understand the difference. Just with that arrow on the top is the vector. It has a magnitude, it has a direction. But with the modulus, it is the length of this vector. It is just one number. Now this is again a vector. It has a direction. What direction is it? Its direction is same as this R. So, but what is it? It is R divided by this one. So this would be a unit vector along A. Would be what? 3 by square root of. But then, did you notice what this is? What is this 3 by root 9, 4 by root 9? What is this? These are exactly our direction cosines. So, or in other words, if your direction cosines are L, M and N, really we can see this is the formula. Unit vector is given by L, I plus M, J plus N, K. This holds for any vector. Here, what is the next question? This is unit vector. Its length is 1. But we need one of magnitude 5 units. So what do? Just multiply throughout by 5. 59 by square root of 29 plus 20j square root of 29 minus 10k by square root of 29. Multiply throughout by 5. And similarly, if you want 10 with length 10, multiply with 10 and so on. Now we have two questions, one on the parallelogram law and the other on the triangle law. What is the triangle law? What is the question about the triangle law? You have a triangle and ABC are the sides of the triangle taken in the cyclic order. That means this is A and this is B and this is C, taken in the cyclic order, and we have to prove that A plus B plus C is equal to 0. But what does the triangle law say? If you take two sides, just two sides in cyclic order, let us take that, which is AB plus BC in the cyclic order, then their sum is represented by the third side, but the one taken from here with its initial point same as A and its terminal point same as B. That means taken in this direction. AC is given as its sum. So bring it over to this side, then what do you have? Minus AC is equal to 0. That means AB plus BC plus minus AC is what? Plus CA. But then what is AB? A. This is B. And this is C. So when you take the sides of a triangle in cyclic order, you get the answer 0. So what is given here? You have a parallelogram and then two adjacent sides A and B are given. A is given by I plus 2j plus 3k, and B is given as 2I plus 4j minus 5k. And what are the diagonals? One diagonal will be A plus B. This one will be A plus B. See, they all have the same initial point A. Then the other diagonal, what will be the other diagonal be? It will be B minus A. So we will get the two diagonals first. So this will be these are the two diagonals. Next, what do we have to find? We have to find the unit vectors. How do we find the unit vector? We find its magnitude and divide it. So take the first diagonal. This is the first diagonal. What is its magnitude? Unit vector along this direction. It will have the same direction as A plus B, but then this is how it will look like. Now go to the second diagonal. What do you see about the second diagonal? What is its magnitude? Square root of 1 plus 4 plus 64. This will be the unit vector. Now, without making any calculations, can you find the direction cosines of this? What was the formula? Any unit vector is actually Li plus Mj plus Nk. So the direction cosines of B minus A would be 1 by square root of 69. This will be the direction cosines. Now now we will start with the second question. What is the question? We need a vector. Let the required vector be xi plus yj plus zk, and let its magnitude be, it's given as 5 root 2. That is given. What else is given? The angle that it makes with the x-axis, the y-axis and the z-axis. What it makes with the x-axis is given by pi by 4. The angle it makes with the z-axis, with the y-axis is given by pi by 2. And we don't know what angle it makes with the z-axis. It is just given by theta. Now, what is cos alpha? What is the letter which we use to represent cos alpha, cos beta and cos gamma? It is L, M and N, right? So, and how are L, M and N related to each other? L square plus M square plus N square is equal to 1, right? But what is L? It is cos square alpha. What is M? It is cos square beta. And what is N? We don't know what it is. We just know that it makes an angle theta. Now what is cos alpha? Cos pi by 4 would be 1 by root 2. Its square would be 1 by 2. Cos beta, cos 90 will be 0. And we don't know what this theta is. So this theta, the square would be 1 by 2, but then its square root would be plus or minus 1 by root 2. But see this word, acute angle. So that means we don't have to consider the minus, just take plus. So then now itself you know what theta is, right? Which angle has the cos value 1 by root 2? We know it is 45. Just by looking at it we know, but then we will do it the way that we want. We want Z. How are Z and cos theta related? What is cos theta? It is the angle it makes with the Z axis. So it will be what? Adjacent side by hypotenuse, that would be Z by R. But then what is Z? It is R into cos theta. R is what? It is 5 root 2. Cos theta is what? 1 by root 2. So Z is 5. You have got Z. What about X? X is R cos alpha, which is pi by 4, which is again the same. 5 root 2 into 1 by root 2, which is again 5. Y is what? R cos pi by 2, which is what? 0. So how does your vector look like? Your vector is 5i. There is no j here. J gone, plus 5k. This is how your vector looks like. What is the next question? We have two parallel vectors. That means what? We can find some lambda such that this is equal to lambda I minus 2pj plus 3k. That means what? Equating your I, what do you get? 3 is equal to lambda, and then equating your j's, what do you get? It is minus 2p lambda, and equating the coordinates, the coefficients of k, what do you get? 9 is equal to 3 lambda. From both of this, you know for sure that lambda is equal to 3. That means when you substitute it here, what do you get? You get p is equal to 2 by minus 6, which means minus 1 by 3 is your answer. Now look at the first question. There is a vector A and we have to find a k which satisfies this condition. That means, now before I go any further, I just want to explain this one important step which tells you an important property of the magnitude. How the magnitude of product of two numbers and sum or difference of two numbers is different. If you have the product or even the quotient, it is the same. If you have the product, you can split the modulus like this. But then you cannot split the sum like this and write it like plus y. This is not possible. Why is that? It is very easy. Just take any example. Take x to be 7 and take y to be minus 2. So both of them added will give you what? Modulus of 5. But then here what do you see? Modulus of x would be 7. Modulus of y would be what? It will become plus 2. So therefore here you will get 9. When you have something like this, remember, inside the modulus you have sum. You cannot write like this. It is not same. But then product, we are safe. When it is product, we can split it and we can write it like this. That is why we get this step. Now dividing throughout with modulus of A, which is non-negative. So the inequality remains as it is. Remember, that is also a very important point. If you have x less than y, if you multiply both sides with a positive number, multiply or divide with a positive number, you will retain the inequality. But remember, if you are multiplying it with a negative number, what happens is that your inequality will be reversed. And again, it is very easy to see with an example. See, 3 is less than 4. Multiply with 2, you will get 6 is still less than 8. But then multiply with minus 2, what do you get? Minus 6 and minus 8. What happens? Minus 6 is greater. So this step also we get. Why? Because modulus of A is positive. Now these are simple steps, but then you have to know basically how this behaves, how modulus behaves, how the inequality sign behaves. Now what does this mean? Again here I would like to add something on this. Let us see what does modulus of k less than or equal to 1 mean. Take randomly any number. What all numbers will you have here? If it is less than 1, 0.4 or minus 0.4, 0.5 or minus 0.5, or in other words, it includes all the numbers between minus 1 and 1. So if you have the number line like this, see, minus 1 lies here, 1 lies here. In this area, you will get all the values whose modulus is less than or equal to 1. So we take all the numbers like this. But then what happens here? This is all the numbers which are greater than 2, their modulus. It has 2, it has minus 2, it has 100, it has minus 100. All their modulus is greater than or equal to 1. So in other words, it includes all the numbers in this direction. See, 200, 300, 400. It includes all the numbers in this direction here, and all the number here, minus 2, minus 100. It includes all the numbers here. So you see what we have done here? We have actually taken the number line and split it into 2. And this 2 together will give you the whole number line. Did you see that? all the values where modulus of k less than or equal to 1 is just this interval. It is just this interval minus 1, 1. And then this will be the union of all the intervals from 1 to infinity and this. So look what we have done here. These two inequalities together will give you the whole of the number line. So please be careful, modulus of k less than or equal to 1 or greater than or equal to 1. If it is less than or equal to 1, you are just talking about this small interval. But if you are talking about modulus of k greater than or equal to 1, you are talking about this entire part and this entire part. There it is the union of this, just this gone. So together, if you put it in this space, you get the whole of the number line. Now coming back to our question, I just wanted to mention this because I see a lot of students, they come to 11th standard, 12th standard, but then the basic things like how a modulus behaves differently with respect to a product or with respect to a sum, they sort of miss they miss the picture. They don't get the concept of it. So I just wanted to explain it to you. So what does this mean? This means k lies in, this is a strict inequality. That means minus 1 and 1 are not included. It is just the values from minus 1 and 1. The end points are not included. Just all the other points between them. So from your first inequality, you get that k lies in this interval. What does your second inequality tell you? Your second condition is that ka plus half of ka is parallel to a. That, or in other words, k plus half is parallel to a. Then what is the value that k cannot take? K should not take. What is it? K cannot be minus half. Right? Why is that? What happens if k is minus half? That means this whole thing will become 0, and that will mean that a is parallel to the 0 vector. That we cannot have. So the first inequality tells us that we need the interval minus 1 to 1. The second condition tells us we cannot have minus half. We should not have that. We should remove that. So that are the values that k can take. It can take the values from minus 1 to minus half, then from minus half to 1, all the values except minus half. Okay? So what do we have? We have a triangle OAC. And what is OA? Its position vector is A. B is the midpoint of AC. That means it lies here. And OB here is B. Now the question is, what is OC? Now we have to find OC. What does the triangle law of addition tell us? Two sides of a triangle taken in cyclic order. That means OA plus AC is equal to the third side, not in the cyclic order, but this way, is equal to OC. So all we have to do is find these two, out of which one it is A. But then what is AC? It will be what? AB plus BC. AB plus BC. So what is AB? Again, for this small triangle, apply the triangle law, then what will you get? OA plus AB is equal to what? It is equal to OB, the third side of the triangle. That means A plus AB is equal to B. That means what is AB? So what is AB? It is B minus A. But then it is a midpoint, right? It divides it into two equal parts. So what is the other part? Other BC, that is also the same. So this is 2 times this. So that means A plus 2B minus 2A. So 2B minus A is your answer. With this we come to the end of this class. Till we meet again, you take care. Assalamu alaikum.